In this example, we're going to look at the effect of preschool on young children. Now, this is an interesting study because there's 12 sets of twins involved. So the twins have very either the similar genetic background and identical home backgrounds, or identical both home and genetic backgrounds. So they match up pretty well. And so in this study, the parents agreed to send one kid to preschool and the other twin stayed at home. And they want to see if there's a difference in IQ between the two kids after a year or two of preschool. So our hypothesis is going to be that preschool makes a difference. Our hypothesis is that early exposure to school affects intelligence. And it's going to be a two-tailed test because maybe the kids that stay at home get a richer environment than the kids who go to school, or maybe the kids at school get a richer environment. And so we're going to do a matched pairs t-test. Matched pairs t-test because we've got 12 pairs of twins and we're going to measure the intelligence after their preschooling and after their homeschooling. So let's go to data analysis, and we're going to do this t-test paired two samples. That's the matched pairs, the paired two sample for means. Click OK. And variable 1 will be the preschool kids. And variable 2 will be the homeschooled kids. Let's get that in there correctly. Whoops. Okay, the hypothesized mean difference is 0. There's label, preschool and home, the alpha, the output range. Let's put that here, an I7. And we press OK. Let's make this readable by widening the column. Let's get rid of all those extra decimal points by number. And so the average for a preschool was 115 and the homeschool was 113. So that's pretty close, but the preschoolers came out higher. So the question is that significant? Can we conclude that that would be the case for all twins in such situations? The degrees of freedom are 11, and the t-stat is 2.11. Now we made a two-tailed test, and the p for the two-tailed test is 0.06. It's not significant. Well, how close were we? Oh, 0.059. So let's highlight that. So our hypothesis was not supported, even though the preschoolers came up a little bit higher. There's more than a 5% chance that we could get that difference just by chance in a sample this size. So we can write a conclusion here. We can say something now. Already in the study, you've given more detail, so we'll just kind of summarize it here. In a study of 12 sets of twins, the intelligence of the siblings who went to preschool, that was M equals 115.17, was not significantly different than those who stayed at home. We've got the mean equals 113.25. And then we have to report the statistics. So control I, T, control I, then parentheses, the degrees of freedom are 11. That equals space 2.11, and the p-value, control I, p, control I, space equals 0.059. So even though there's a slight difference, it wasn't significant. And so we have to conclude that we don't have strong evidence that there's going to be a difference in IQ for kids that go to preschool and those who stay at home when they're little kids.